Hi, so in the last videos we discussed about how to solve separable equations and linear first order linear differential equation by using the techniques, the separable method or the linear method way. Okay, so now we want to use those techniques to solve some real life problems. Okay, so first of all I want to show you how to solve a mixing problem. Mixing problem is like in a tank, okay, there is certain water or any type of solution there that has a salt or any kind of solute, okay, and then a water or the solution is added with certain rate, with certain concentration of the solute, and it is going out with certain rate. Okay, so you want to know what will be the amount of the solute, or what will be the quantity of the solute that is left after a certain time t. Okay, and so these kind of problems we want to use the differential equations that we learn, the solution techniques to solve this type of problem. Let us first write down the formula first. Consider a tank containing salt is the solute, okay, and water is the solvent, I guess. Salt is the solute, and water is solvent, right? So assume that the salt at concentration of CIT flows into the tank at the rate of RIT. Okay, so the rate is RIT. CIT is the concentration of the salt or the solute. Okay, for example, 5 gram per liter or 10 gram per gallon, like that. Okay, flows into the tank at a rate of RIT, meaning, for example, 5 gallon per minute or 10 gallon per minute, like that, and simultaneously flows out with rate ROT. It is flowing out rate, this is flowing in rate, and this is the concentration, so the inflow concentration. Okay, if the salt in the tank is well mixed, then the concentration of the salt in the outflow is QT over VT. So this is the concentration of the salt. Okay, QT is the quantity of the salt in the tank, okay, and VT is the volume of the solution. So QT divided by VT will give you the concentration of the salt in this tank, okay, at any time in the outflow. So that will be the concentration of the salt in the outflow, of that solution. Okay, where QT is the amount of salt, QT is the amount of salt, and VT is the volume of solution at time t. Okay, QT over VT is the concentration of the salt or the solute. Then the rate of change of the amount of salt or the solute in the tank is dq over dt. That is, Q is the amount or the quantity of the solute, or in this case it is salt, okay, is the concentration in the inflow times the inflow rate minus concentration of the outflow times the outflow rate. Okay, so this rate of change is rate in minus the total is the rate out. So outflow rate times the concentration of the salt in the outflow, where Q at 0 is Q0 and V at 0 is V0, where the volume VT satisfies dV over dt equals to Ri, inflow minus outflow. So sometimes the inflow is bigger than the outflow rate. That means at that time the volume will keep increasing, right? And it will, one time it will be full and it will start to overflow. If the outflow rate is bigger and the inflow rate is smaller, then in that case the volume will start to decrease from the initial volume, okay, the beginning volume, and at one time it will be 0, or it will be below this outflow or the sink level. Okay, all right, so let us do one example and then things will be clear. We'll do a couple examples here. So the first example is, suppose there is a salt and the water solution in a tank. There is the total solution in the tank is 200 liters, in which 20 gram salt is mixed there. Okay, a tap or from a pipe, the solution of water and salt is coming in with the rate of 4 liter per minute, where the concentration of the salt in the inflow is 1 gram per liter. And from the outgoing pipe, there is a 4 liter per minute. The same rate, same inflow rate and the outflow rate are exactly the same. 4 liter per minute is going out. So in this situation, you see that whatever amount is coming in, the same amount is going out, right? Same rate. That means the volume of this tank, this volume of the solution in this tank will be same, 200 liters all the time. Okay, so the question here is find the solution for quantity of salt. So what will be the equation? What will be the solution function for the quantity of salt? And what is the quantity of salt after 10 minutes? So you want to know what is the quantity of salt in that tank after 10 minutes. That's what you want to know. Okay, guys. So let us solve this. So to solve this, let us first of all write down what are the given things. Okay, so the given things here is, so V at 0 is 200 liters, right? Q at 0 is 20 grams. That is the amount or quantity of salt in this tank, right? What is RIT? The inflow rate is 4, right? What is the CIT? That is concentration of the salt in the inflow water, right? That is 1. And then what is ROT? The outflow rate is 4 liter per minute. And then, so what will be the concentration of the salt in the outflow? It will be QT. Let's say QT is the concentration of the salt in the tank, and then VT is the volume, right? So that will be the concentration in the outflow water, right? That will be QT over VT is the same all the time, right? Because the volume of this is not changing. It is 200 liter all the time. So over 200. Okay, guys. So here on this problem, what we are going to do is we want to use this equation, this formula, to find out the solution. So what you get is dq over dt equals to ci is 1 times the 4 minus q over 50 times r sub o is out. So that is 200, right? 200 times 4, that will be 4, right? Minus 1 over 50, because if you divide by that, and then q. So you want to solve this equation. What is q at 0 though? Q at 0 is also 20 gram, right? Now what you want to do is, this is a linear. So what I want to do is, I want to take this and that, and then use the method to solve the linear equation. Okay, so dq over dt plus 1 over 50q equals to 4. Okay, so let us find out the integrating factor. Integrating factor will be e to the integral 1 over 50 dt. That will be e to the 1 over 50 t. Okay, we multiply all these terms by that value. So e to the 1 over 50 t dq over dt, right, plus e to the 1 over 50 t times q over 50. You can write 1 over 50 times like that, and then equals to e to the 1 over 50 t times 4. That's what you get. Okay, so what is the left side? This implies, so the left hand side will become d over dt. So the integrating factor times the y value, that is q times e to the 1 over 50 t. That is the left side. And in the right side, what is that? So it will be 4 times e to the 1 over 50 t over you get 1 over let me copy that, because I'm not integrating 8. Okay, so let me copy the same thing and I'll integrate now. Okay, guys, if you integrate, what do you get? on both sides. If you integrate on both sides, that integral and the derivative will cancel out. That will be the integral there. So basically you will get q times e to the 1 over 50t equals to 4 times, what is the integral of e to the 1 over 50t? It will be e to the 1 over 50t over 1 over 50, right? And then plus c. What do you get? If you do that, you will get q times e to the 1 over 50t equals to, that 1 over 50 becomes 50 on the top, right? So it will be 200 e to the 1 over 50t t, right? And then plus c, right? Now divide both sides by e to the 1 over 50t, e to the 1 over 50t. So e to the 1 over 50t, exactly the same technique we are using, right? 1 over 50t. So what do you get? You get qt equals to, you get 200, right? Qt equals 200 minus you get c times e to the negative 1 over 50t. That's what you get. Okay, guys. Now, what do you do next? So, the next thing you do is you want to use the initial condition. So, let me write down here. Using q at 0 is 20. We get 20 equals to 200 minus c, right? Because if you plug in t equals to 0, you will get e to the negative 150 times 0 will be just e to the 0, that is 1. So what do you get for c then? So c will be, let me see what do you get for c. By the way, is this minus? I think it is plus, right? So plus c. So c is basically, c is negative 180, right? So what is the final answer? Final answer is qt equals to 200 minus 180 e to the negative 150 t. That is the final answer. So what is the next question? In the part B, find the quantity of salt. This q stands for the quantity of salt, okay? So that is qt. Q10, this is what it is asking. It is qt. It is asking qt. So this is the answer for the first problem. And for the second problem, what I want to do is I want to find out q10 after 10 minutes. So q10, meaning you plug in t equals to 10. I think if you plug in t equals to 10, I think you will get 200 minus 180 times e to the negative 1 over 50 times 10, right? So you will get 52.63 or 64, I guess. 52.64. This is what you get. Okay, this is the amount of the salt or quantity of the salt after 10 minutes. Okay, guys. So this is basically these are the two final answers for this problem. Now, the next thing is, see, what is the difference? So I'm taking the same, almost same example. Only the difference is, instead of 4, I'm taking 5 here. Okay, what is happening there is basically the tank is going to be empty because the inflow rate is smaller than the outflow rate. Okay, the inflow rate is smaller than the outflow rate in this case. Okay, guys. So in this case, at some point of time, it will be the tank will be empty. Okay, so again the same thing. There is a tank that has 200 liter of solution with 20 gram of salt. Okay, a pipe has the solution is coming in to the tank from a pipe with 4 liter per minute with 1 gram per liter of the concentration of the salt, and it is going out with 5 liter per minute. Okay, now you want to find the solution for quantity of salt. Okay, so let me write down the question. Find the solution. Find the solution for quantity of salt. Okay, so the next thing is you want to know when will that be. Let us say that when will the tank has 30 gram of, or let's say smaller number. Okay, when will that has, let's say, 15 gram of salt. Okay, so in this example almost everything is same except there is a 5 liter per minute the outflowing rate. Okay, so the question is find the solution for the quantity of salt, and when will the tank when will the tank has 15 gram of salt. That's what the question is, right? So how do I do that? Exactly the same way. Okay, so what is given there is so V0 is 200. Okay, Q0 is 20 gram. Okay, RIT equals to 4, CIT equals to 1, ROT equals to 5, right? Okay, now we need to find out VT. So how do I find out VT? Because you see that the volume will start to decrease, because after 1 minute the 4 liter is coming in, 5 liter is going out, so 1 liter will be 1 less liter, right? After 2 minutes 2 liter less, after 3 minutes 3 liter less, and so on, right? So how do I find out the volume? Because the volume is changing here, volume is not constant here. Okay, volume is changing. So how do I find out the volume? This is the formula to find out the volume. Okay, so to find out the VT we use dV over dt equals to Ri minus Ro, and then V at 0 equals to V0, right? So what you do here is dV over dt equals to 4 minus 5. That's what you get, right? And then here you get V equals to, so integral of -1, right? Because that value is -1, right? -1. So integral of -1 is -t plus c. You see that? So what is the value of c? So value of c is 200, right? You see that? So if you use V0 equals to 200, t equals to 0, v equals 200, you get c equals to 200, right? So v of t equals to basically 200 minus t. That's what you get, expression for v, okay, or vt you'd say. Formula. So we have now everything that we need. Okay, so we did that already. We have q. So qt be the amount or quantity or amount of the salt at time t. Then dq over dt equals to, you have the formula is Ri times Ci, right, minus Qt over Vt times Ro, right? So outside one. So what do you get there then? So Ri is 4 times 1 minus Qt is Qt, and Vt is 200 minus t now, right? And then times, this is 5. Okay guys, so we want to solve this equation. So what you get is dq over dt equals to 4 minus 5 over 200 minus t times q of t, right? And then q0 is 20 again. So this is the equation. Now use exactly the same technique that we used before to solve. First of all, let us write in the standard form. So what do you get? You get dq over dt equals to, oh, not equals to, let me write down, let me move that to the left side, plus 5 over 200 minus t qt, or q equals to 4. That's what you get, right? So how do I solve this? Just find out the integrating factor again. So you need to find out the integrating factor, okay, and then find the values there. So what is the integrating factor? So integrating factor is so if equals to e to the integral of 5 over 200 minus t dt. That is same as e to the 5 1 over 200 minus t dt. So what do you get? So how do I find out the integral of this? What is the derivative of the denominator? -1, right? So there is no negative 1. So you can write negative, negative, and then so this is negative 5 e to the negative 5 and then natural log of the denominator, right? Because we know this formula. If you have a function, the derivative on the function on the top and then the original function on the bottom, dx will be natural log of f, the natural log of the denominator. That's what I'm doing here. Natural log of 200 minus t, right? That's what I get. So 5 times natural log. So how do I remove this e and ln? So you need to move this to the top. So what you get is e to the ln 200 minus t to the negative 5, right? So if you write in better way, if you want to write the better way, e to the ln 1 over 200 minus t to the 5th. So e and ln cancel out. So what is the integrating factor then? The integrating factor is 1 over 200 minus t to the 5. This is what you get. Now you need to find the you need to multiply the both side of this equation by that value. So you get 1 over 200 minus t to the 5th times dq over dt plus 1 over 200 minus t to the 5th times 5 over 200 minus t times q equals to 1 over 200 minus t to the 5th times 4. That's what you get, right? So how do I find out that? Is the left hand side is directly d over dt, q is just q, and times the integrating factor 1 over 200 minus t to the 5. That's what you get, equals to this is 4 over 200 minus t to the 5, right? Now let us integrate on both sides. What do you get? Integrate this, will cancel out with that and integrate here. So you get q times 1 over 200 minus t to the 5, okay? And then equals to 4 over 200 minus t to the 5. So integral, so 4 over integral of this, okay? So how do I do that? You have to do u substitution. You said if you do u equals to 200 minus t, so du will be a negative dt. So negative will go out there, right? So this will be u to the 5, and then so what do you get there then? You'll get so negative du, right, over u to the 5. You see that? So what do you get? This is 4 u negative 4 u to the negative 5 dt. That will be negative 4 u to the negative 5 plus 1, integral of that over negative 5 plus 1, that is 4 and 4, right? So it will be u to the negative 4. That's what you get. So u to the negative 4 means what? That is same as 200 minus t to the negative 4 plus c. Don't forget that plus c thing. So what you get ultimately is therefore q. Now so this is the left hand side, this is the right hand side. Let us divide this by 200 minus t to the 5th, okay? Therefore qt equals to multiply by that. So let us multiply both sides by 200 minus t to the 5th. 200 minus t to the 5th. What do you get? You get qt equals to there is 200 minus t to the 1, because there is negative 4. If you multiply by 5, then 5 minus 4 will be positive 1, plus c times 200 minus t to the what? 5. So you need to find out the c though. What is c? You need to plug in q0. Where is q0? So q0 is 20. So 20 equals to 200 plus c times, oh my god, 200 to the 5th. It's a huge number there, right? Qt equals to, oh, this is not 200, this is 20, right? At the beginning it is 20. So negative 180. So what do you get? What do you get here is c equals to subtract 200 on both sides, negative 180 over 200 to the 5th. That's a very, very, very small number. C is a very, very, very small number, okay? So now what you want to do next is you want to find out what is the time? the tank has 15 gram of salt. Okay, when the tank has 15 gram of salt, that's what you want to find out here. Okay, guys. So how do I do that? So you see that C is very small. Let me find out what value is that. I think we can take C almost 0 there. Okay, why? Because if I do 180 divided by 200 to the 5th, I get 0.000, 10 zeros and then 5. Okay, so it is almost 0. Let me write down this. So which is almost approximately 0. So what you want to find out next is you want to know what will be the when will be the concentration of the salt is 15 gram. Okay, so that's what you want to know. So let us do that part. Continue from here. Okay, guys. So continue from here. So it's what is the final answer? Let me write down the final answer. Okay, so final answer is actually QT equals to 200 minus T plus minus, because C is minus, right? So minus 180 over 200 to the 5th, and then 200 minus T to the 5. That's what you get for the solution. But this is almost 0. You see that? This guy is almost 0 there. Okay. So although there is a times 5, but since this is almost 0, so I'm ignoring this term to find out to answer the second question. Okay, because it is hard to solve to the 5th power of T. So what I'm doing here is when will the tank? So let the tank will have 15 gram of salt after T minutes. Then what happens is QT equals to 200 minus T. I'm ignoring this because this is very very small number. So one of the things that I want to note here is so this number is big, right? Because 200 minus whatever T you take, if T is small number, then this number will be very big because it has power 5, and this number is very small, right? So you can think like this is almost 0 times a big number, maybe not exactly the 0, but this is what we can do best because these are very big number and it is hard to solve for T. So what we do is we are just ignoring this term. I mean, another way you can do, if you want to be exact, then what you can do is you can just plot this on the graph, okay, in your calculator, and then plot the horizontal line y equals to 15 on the graph, right? This is what you will get. If you draw that, this is what you will get. So you will get like 20 at beginning, it is 20, and it will go like that, and then 15, y equals to 15 will be somewhere here. And this point of intersection is 184.99. This is what you get. Okay. So either way, you will get almost 185. So after 185 minutes, the concentration or the volume, not the concentration, the quantity of the salt in this tank will be 15 gram only. So the concentration will increase. I mean the quantity will increase for some time and then it starts to decrease. The reason is because see, the quantity is very low. In 200 liter of water, there is just 20 gram of salt, but it is coming out with 1 gram per liter. So every minute, it is coming in 4 liter of water with 4 gram of the salt, right? So this is what it is happening. So for some time, the quantity of the salt will increase, and after that, it will start to decrease because the whole solution will start to decrease. Okay, so it was not very easy to solve for T when you plot 15 here. Okay, so what I did here is that I ignored because this was very small number times a big, it is finite number, whatever value of T, it will be finite number, right? So it will be almost 0. That's why I solved it for big T. I got almost 185 minutes. Okay, guys, thank you.